This is a empirical formula calculation, and to do this we use our Mr. Moles triangle, and we start off with the mass, and the mass is given to us in the question, and we're told there is 0.92 grams of the sodium and 0.32 grams of the oxygen. The next thing we do is record the MR, which is atomic mass in this case. So sodium is 23 and oxygen is 16. Now what we're going to do is work out the moles. So if I use my pen here, we're trying to work out the moles. So the moles is mass divided by MR, which is why we've written it down this way. Because we do the top number divided by the bottom number, so let's just do that on my calculator. Divided by 23 is 0.04, and 0.32 divided by 16 is 0.02. Okay. The next step is divide by the smallest number. So the smallest number in this case is 0.02, so that's going to become 2 and 1. So for my empirical formula is Na, that gets a 2, and just O1, we don't need to write the 1 down. In terms of marks, there's 3 marks available. They're going to give you a mark for working out the ratio, working out the actual whole number ratio, and then you've got the formula in there as well. Sodium reacts with water to form sodium hydroxide solution, and hydrogen. Complete the balanced equation for this reaction and add any state symbols. Let's do the state symbols first. So sodium in here is a metal, which means it is a solid, so that's an S. Water is a liquid, so we put an L. It tells us that sodium hydroxide is a solution, so solution means it is aqueous, which is AQ, and hydrogen, hopefully we remember that hydrogen is a gas, so that is a G. Now let's just balance this. So I'm going to use a method to balance this. I'm going to write down the elements involved in the each half of the equation. So on this side here, I'm going to now count these up. So I've got 1 sodium, I've got myself 4 hydrogens and 2 oxygens. On this side, I've got 1 sodium, I've got 1 oxygen. Now be careful with the hydrogens because there is 1 here, but there's 2 here, so that gives me 3 in total. And you can see that my hydrogens and my oxygens are not balanced. I'm going to have to do something about it. I need 2 oxygens on this side to make it balanced. So how can I get 2 on this side? If I put a big 2 in front of here, let's just do that. A big 2 goes there, but that's going to give me 2 sodiums. And that's going to change that to 4. And now it's got 2 oxygens. Okay. If I come back over to the other side, how can my 4 and my 2 is okay. That's good. But I need to get 2 sodiums. So to do that, all I've got to do is put a 2 in front of that, and I've got a balanced equation. In this next part, it says we've got equal sizes of the metals, lithium, sodium, potassium are added, and a flame is produced with the potassium. Because what's the reason why? So it's not because it's the softest, that's rubbish. It has the lowest melting point, not because of that. It's the only flammable metal, not because of that. This is the most reactive in that bunch, and it's producing hydrogen, and it is also able to ignite it because it is more reactive. Okay, this next one is a continuation of the experiment. So teacher has demonstrated it, and you've got a set of results here, which is describing the way the metal sits in the water, the way it reacts, and how much bubbling it produces. Remember, bubbling means it's producing a gas. Describe in detail how the teacher would demonstrate this experiment safely, showing how the results give the order of reactivity. Okay, so it's kind of, in this question, just two parts to this. First part is how we're going to do it safely, and the second part is let's show the results. Okay, so demonstrating it safely. What we do is our precautions is that everyone, including the teacher, wears safety glasses whilst we do the experiment. We have a safety screen up, and the class sit back away from the demonstration. There's a large trough that's to allow any of the heat to be absorbed and just make it safe, and that contains the water. Some same amount of water each time because we're going to do a comparison of the way these react. We take the metal out from our container using tongs or tweezers. We don't use our hands to do that. And we place the metal on a tile, and then we cut a small piece to make it safe to be added to the water. We want too large a piece. And we remove any oil. Normally you put it on a piece of tissue. It will absorb the oil and leave the metal free from oil so it can react. In terms of getting the order of reactivity, you can see from the way it's been done, potassium is producing the most hydrogen, or producing hydrogen more quickly, and it's also moving the most on the surface. Sodium is described in the middle somewhere, and lithium is the least reactive because it's producing hydrogen very slowly and is moving slowly on the surface of the water.